Set theory and logic, page 1. So let's first talk about sets. We classify items into sets every day, whether we realize it or not. Like a car, SUV, truck. Is something a fruit or vegetable? Do we like something or don't like something? We could have other examples. We use sets to understand the relationships between groups. As with most things, sets have their own set of vocabulary and symbolism, and that's what we'll study this unit. So let's start with some vocabulary. A set is any collection of distinct or different objects. Each object in the set is called an element of the set. Given a set given a set A, if U is an element of A, we would write U is an element of A. If the element U is not an element of A, we would write the following. So you see we have an element symbol just with a slash crossed through it. So examples of sets and elements are: you're an element of the set of all students in this class. The ace of spades is an element of the set consisting of a deck of cards. The number 4 is an element of the set of even integers. So we just talked about integers. Maybe you've forgotten what integers are. And this will give us an opportunity to do this as we talk about different sets of numbers. So I believe some of you have seen this before. If you'll notice, we have the set of integers and there's a symbol for it. That would be like your positive and negative, what would normally called counting numbers, and then 0. Now this would be an infinite set because there's an infinite number of elements. So hopefully that looks familiar to you. The set of even integers. Remember, even numbers are numbers that are divisible by 0. And similarly, that is an infinite set. The set of rational numbers. Now you'll notice I listed the 2 infinite sets. And then a set of rational numbers, I'm going to go ahead and describe them. So a set of rational numbers is a real number that can be written as a ratio of 2 integers. Well, you see what an integer is, and I think you see where the term rational number comes from. Basically anything that can be written as a fraction, but you have integer in the numerator and the denominator. Set of real numbers would be the set, or I guess it would be the rational and irrational numbers. Now we just defined what a rational number was. Remember that irrational numbers are non-repeating, non-terminating decimals. Examples of that would be like square root of 2, the number pi. As we have demonstrated so far, a set can be defined by describing the contents of the set or by listing the elements of the set enclosed in curly brackets, which we call braces. Okay, so additionally we can describe a set by using a rule. And here's some examples. I have the set S would be X such that X is an element of the integers and it is between -1 and 1 inclusive. So that would be the set of all integers between -1 and 1, inclusive. All right, so let's list the elements of this set. Looks like it starts at -1. We can include that. The next integer would be 1, and then the last one would be 1.